As the first article in a series explaining the top most popular databases, let's take a closer look at the Redis database. Redis is an open source in-memory data structure store widely used as a cache, key-value database, and message broker. Moreover, it is oftentimes ranked as the most popular key-value and one of the top NoSQL databases. Before we dive into the Redis database details, let's take a minute to learn more about its history. Redis was created in 2009 by Salvatore Sanfilippo, also known as Antires. Its name comes from the remote dictionary server and was created when Antires was working on a web logs analyzer for his startup. Initially, the prototype was written in the TCL programming language and was later converted to C. After a couple of weeks, Salvatore open-sourced the project, which quickly gained popularity due to its speed, flexibility, and ease of use. 6 years later, Sanfilippo founded Redis Labs, a company that provides support, services, and products for Redis. Nevertheless, at the moment of writing, Antires is not a maintainer anymore, and the company itself is called simply Redis. With all of that being said, let's learn how Redis works and what makes it different. So, as mentioned above, Redis stores data in memory, which makes it much faster than most of DBMSs, which persist data to disk. But does it really mean that the data are lost if the server running Redis restarts or goes down? Not exactly. Redis was designed to combine ultra-fast data access and modification using in-memory storage with data persistence to disk. To prevent data loss, Redis supports writing data to disk using different storage options such as snapshotting and append-only file logging. So if the server restarts, the data are simply restored to memory from the disk space. It's worth mentioning that although the Redis database comes with support for plenty of different data structures, it doesn't have a support for queries known from other databases. It is a key-value store and the commands are rather direct instructions than fully functional queries. So now, let's take a look at a couple of Redis advantages. First of all, speed. At this point, we shouldn't be surprised that the performance is a huge advantage of Redis. That's what it's been designed for, and disk-based solutions simply cannot compete with their in-memory rival. Latency measured in microseconds, not milliseconds. Microseconds brings a lot to the table. Secondly, a huge and active community. And although I will use this argument pretty often in this series, we can never forget about it. A large community with a tremendous amount of materials available online has a huge impact on the ease of Redis incorporation. Time spent on searching and debugging can be significantly reduced and the access can be used much better. Moreover, the Redis database is supported by a wide range of programming languages and comes with plenty of libraries and solutions which we can use to make our lives easier. As the next thing, data type support. Redis as a key-value store comes with support not only for string values, but also for various other data structures. We can use hashes, lists, sets, sorted sets, geospatial data, and even JSON and graph using dedicated modules. Depending on the type of value used, Redis lets us use dedicated commands like set union, differences, and list sorting. Following, data persistence. And as I mentioned previously, by design, Redis combines low latency read-write in-memory operations with data persistence. So in case our server goes down or simply restarts, the data won't be lost. Or technically with the default snapshotting every 2 seconds, we'll lose a maximum of 2 seconds of data. Moreover, it's easy to use. Instead of sophisticated queries, we can communicate with Redis using a pretty simple command line interface. Lastly, Redis comes with many additional features like transactions, PubSub, or Lua scripting. So, with all of the above benefits being covered, let's take a look at the Redis disadvantages. As the first one, it can be expensive with large datasets. And although in-memory storage gives Redis a huge performance advantage over disk persisting databases, additional memory can be much more expensive. Whatsoever, key is management. Redis is a key value store and it is our job to define and maintain the appropriate key structure. Moreover, it is not designed for complex queries and relationships. This makes it easy to use and fast, but it can also limit the ability to model complex relationships between data. Finally, it's single-threaded. Redis is a single-threaded, which means that it can only process one command at a time. This can limit its performance when dealing with a large number of concurrent requests. So with that being covered, let's take a look at what can it be used for. Firstly, caching. Redis database can be used to store frequently accessed data in memory for fast access. It will be a great add-on everywhere where latency matters. Secondly, session management. It can be used to store user session information like preferences and login status, for example. This can help us handle user requests much faster. Thirdly, real-time analytics, and basically this was the main use case for which Redis was brought to life. Its support for data structures allows for fast and efficient calculations and real-time metrics. Additionally, leaderboards. Thanks to the support for sorted sets, it can be used for the easy ranking of items, making it well-suited for implementing leaderboards in our applications. Moreover, messaging. With PubSub messaging, we can easily implement message queues and real-time client-server communication. And lastly, it can be a great choice for product catalogs and product information storage. Of course, these are not all the use cases, and if something comes to your mind, then let me know in the comment. As the last thing, let's take a look at a couple of known companies which use the Redis database. When we look at the list of the most popular ones which were the first to adopt Redis in their technology stack, we'll see GitHub and Instagram. Nowadays, when Redis database has a well-established position in the market and proven for many years that it can be trusted and can bring value to almost any project, it can be found on the backend of many known companies like Uber, Stripe, Twitter, Slack, Craigslist, and even Alibaba. So that would be all for this video explaining what exactly Redis database is. Together, we've learned more about its history, use cases, advantages, as well as the disadvantages and the companies using it to deliver their products. I hope you enjoyed this series covering the most popular databases, and if you enjoyed the content, please leave a comment and let me know about your thoughts.